This next video on quadratics is going to look at imaginary numbers. But first, let's go back to an example that we've done before, x squared minus 9, where we shift the parabola down 9, and if we were to factor that, we would get x minus 3, x plus 3. And we know the solutions are x equal 3 and x equal negative 3. If I take the parabola and put the solutions on the graph, I would have the parabola going through 3 and negative 3. Now, let's talk about what would happen with a parabola that is x squared plus 9, where we shift the parabola up 9 instead of shifting it down. Notice that I don't have any solutions because I'm not crossing the x-axis. But if you have a parabola that is crossing one time at the x-axis, then you're only going to have one real solution. Real meaning like a real number. If you have a parabola that crosses in two places, you'll have two real solutions. But if the parabola doesn't cross, then there are no real solutions. However, there are two imaginary solutions. All right, so why imaginary numbers? Let's just take, for example, the square root of negative 9. You've probably seen this before. You think, okay, I can't do the square root of negative 9. But if I were to split them up, which we've talked about because we can do multiply two numbers inside of a square root, so we can split them up and make it a square root of negative 1 and a square root of 9. So if I did that, I would have the square root of negative 1, which I know that I can't actually calculate. However, what I can do is represent the square root of negative 1 with just a small I. Now, if I were to go ahead and square root the 9, which I've shown here, then I would have I for the square root of negative 1, and then I could go ahead and take the square root of 9, which is 3. But let's write this a different way. Let's put the coefficient, the 3, always in front of the I. Okay? Now that would be my answer. So now let's go back to our previous example of x squared plus 9 equals 0. Remember, this is the y. So if I were to subtract 9 over on the other side, I would have the square root of x squared and the square root of negative 9. Remember, when you do a square root, you always have to do the plus minus. And on top of that, I have a negative 1 that's inside of the 9 that we saw just a minute ago. So I'm going to go ahead and put that I out there. And then the square root of 9 is 3. So in this case, there are two solutions. I have a plus 3i and a minus 3i. All right, now let's work on another problem where we have to solve for x. And this is going to end up being negative. If I subtract the 11 over, I get negative 48. I'm going to divide by 2, and then that'll give me negative 24. If I square root both sides, like we've done before, then I'll have x equal plus or minus the square root of negative 24. I need to simplify that, and I also need to take and make it an I for an imaginary number. So I'm going to split up the negative 1 and the 24. All right, so I get x equal plus or minus, then negative 1, or square root of negative 1, becomes an I, and I have left over negative 24, which I can still break that down. So if I break it down, I will have the square root of 4 and the square root of 6. Because only one of those numbers square roots, the other one's going to have to stay in the square root sign, or what we call the radical sign. Plus or minus, take the square root of 4, which is 2, put the I in there, and then the square root of 6. Notice after I did the square root of 4, I put it in front. I put the 2 in front because that's like the coefficient. I put the I, and then I write the square root of 6. All right, that is my answer for X for this problem. Okay, so a complex number is a whole number with an I. Both of these are complex numbers. This 8 is a whole number, or a real number, with an I, and this here's your real number here with a 4i. This is the imaginary part, this is the real part. Okay? All right. Let's go ahead and talk about adding these together. An I is going to work like any other variable or number. It has to follow some of the same rules, including like terms. So if I do 8 plus 5 is 13, and then add the 4 and the negative 1, I'll get 13 plus 3i, which this is a complex number right here. I can do this, I can add or subtract. And I also have to watch out for like terms. Okay, so let's just talk about some of the rules that you're going to use with, or that an imaginary number is going to follow. Again, you're going to want to follow like terms. So only add or subtract I terms with I terms. Watch PEMDAS. You're still going to have to use that. And I can follow some of the same rules that variables follow with multiplication, division, and distribution. And we're going to see some of that right now. Okay, so let's say, for example, the square root of 3 times the square root of 3 equals the square root of 3 squared. Do you agree? And what would that equal? A 3. Really, the square root of something squared is just going to be whatever's inside of the radical sign, whatever's being square rooted. Okay, so let's think about it again. If I have the square root of negative 1 times the square root of negative 1, then I have the square root of negative 1 squared. So therefore, that answer is whatever's under this radical sign. So if the radical sign has a negative 1 and it's squared, then answer is going to be negative 1. Let's think about that again. If the square root of negative 1 is an I, and the square root of negative 1 is an I, and I'm multiplying them, then I have I squared. So that means that I squared equals negative 1. So when you see an I squared, you're going to say, oh, okay, that I need to replace it with a negative 1. All right, here's an example. 4i times negative 2i is really negative 8i squared. Okay, what do I replace the I squared with? A negative 1. So in other words, the negative 8 was just a negative 8 times a negative 1, and that made positive 8. Okay, next example. We're going to do some distribution or FOIL. I've just got two complex numbers, 9 minus 2i, it's the first one, 9 plus 2i, and I'm going to FOIL first, outer, inner, and last. Okay, 9 times 9 is 81, plus 18i. Did you notice the 9 and the 2 make 18i? I can go ahead and multiply those. That's okay. Multiplication does not follow this particular rule for like terms. Okay, negative 18i, and then negative 4i squared. All right, the 18i's make 0, So I'll have 81 minus 4, and then the I squared becomes what? A negative 1. So now I have 81 plus 4, and the answer is 85. Notice how the 81 and the 4 end up being 85. The I squared became negative 1, which made that I squared go away, and the 18 i's in the middle ended up being 0. So in other words, everything, all the i's went away, and I only have one number now. Okay? If you've seen this before, this 9 minus 2i and 9 plus 2i are conjugates of each other. Okay? We're going to see this again. Next problem. I have 7 plus 5i over 1 minus 4i. Okay, here's the rule. Just like with radicals or square root, you cannot have a square root on the bottom of the fraction. We have to get rid of it. You also cannot have an I on the bottom of the fraction. We're going to have to use the conjugate again. So what do you think goes on the bottom of this fraction? It's got to be opposite of 1 minus 4i. I put the 1 and the 4i in there, take the middle sign, and it needs to be opposite. So it's going to be a plus. Whatever you do on the bottom, you have to do on the top. Okay, now I have to FOIL. I'm going to FOIL just the top, and I'm going to FOIL the bottom. So 7 times 1 is 7. I'll have 28i plus 5i plus 20i squared. Notice I just FOILed the top. The I squared becomes a negative 1, so I'm going to have negative 20. A negative 20 plus 7 is negative 13. Notice that I'm putting the real number in front. The imaginary number goes after the real number. So negative 13 plus 33i. Okay, there's the top of the fraction. Let's do the bottom. Okay, so I'm FOILing 1 plus 4i minus 4i minus 16i squared. Okay, the I squared becomes negative 1. All right. Notice that if the I squared is negative 1, that negative 16 now becomes a positive 16. And if I add 16 plus 1, I get 17. Also, the 4i and the 4i become 0. And this is my final answer. Okay, that's it for imaginary and complex numbers. You've seen an example of each type. When you go to review this, you can review this video. And also there will be some extra examples so that you can watch how the imaginary number is used to solve quadratic equations or to simplify some of these expressions.